of the conference, and
today, after the
today
NLP
after the NLP roundtable, we are moving on with the invited talk, and it is my great pleasure to introduce Jeremy Barnes. We worked together for several years in the language technology group at the University of Oslo, and then a very sad thing happened. Jeremy left us to become an assistant professor at the University of Basque Country, where he's now. We are, well, not we, I guess. Jeremy is organizing some of our shared tasks on structured, like fine-grained sentiment analysis next year with my humble help. And today's talk, I guess, will touch this topic quite a lot, but maybe many other aspects as well. And yeah, I guess we have how much time here? An hour and a half, but yeah, I really hope that we will have plenty of time for questions and discussions. And I really hope that this talk will be interesting not just for NLP people, but also for those from other tracks of the conference. Since, as we discussed half an hour ago, like one of the strong points of this conference is its multimodal and interdisciplinary character, right? So I do hope that Jeremy's talk will be of great interest to all of you and to all those who are joining us in Zoom. Okay, without further ado, the floor is yours, Jeremy.
Thank you. Okay, thanks a lot for having me here. Like Andre said, I'm going to be presenting this. I just started as an assistant professor at the University of Basque Country, and I'll tell you a little bit about myself and how that relates to this talk now. So the first thing, motivation. Why did I choose this title? This has a little bit to do with me and a little bit with the state of things in NLP these days. So for me, when I started my, let's say, NLP research career, I started working on emotion analysis and sentiment analysis. And at the time, I would say most of the data sets that I worked with were sentence classification data sets, right? This is pretty common. I think it's still quite common for a lot of data sets to be sentence classification data sets. Some examples of tasks that are done at sentence level are things like sentiment classification, which I've mentioned. It's going to be a kind of running gag. So one of the examples I'll give throughout the talk are going to be sentiment, since it's something I've worked with a lot. Other things, topic classification, language identification is often done at sentence level, and intent classification. So in chatbots, whenever you want to know, somebody asks a question, you have to decide what kind of question is it, what are they looking for? These kind of things are often done at sentence level. What I wanted to show with this is that there's a lot of tasks. It's not just something that's specific to sentiment. It's something that's relatively broad that we do when we're working with NLP. And another thing that I'd like to point out is how prevalent these sentence classification tasks are in benchmarking models. So when we have a model, we want to know how good it performs. We have a tendency to go towards these. So if you know the multitask benchmarking data set called GLUE, it was a very popular data set. It worked with a lot of sentence classification tasks. Also, there's a more recent one called the Dynamic Sentiment Analysis Benchmark, which again, it's an adversarial version. So I'll talk a little bit more about it, but it's just to show you that this one is also there. And also, whenever people start benchmarking these large language models these days, a lot of these are also done with sentence classification data sets. So it's something that happens, you find in a lot of tasks. I'm going to speculate a little bit about the reasons for this. One of the main ones is just the fact that it's easier to annotate this. So depending on the task, there's a times you can semi-automatically annotate many of these things using star ratings or user ratings for sentiment analysis, or you could do it with other ways, some kind of metadata. And at the same time, if you're just actually manually annotating, it's a nice sized chunk of text to present to an annotator. So it makes things a little bit easier. And because it's easy to annotate, it has a tendency to become, have larger data sets associated with it. So this is, you get large data sets, which is better for deep learning models. So it has a tendency to propagate in that way, right? And also, because the data sets are larger, you can have relatively large test sets as well, which helps between whenever you need to have statistical differences between models. It's relatively easy to calculate. But conceptually also, this allows for kind of simpler train test procedures, right? You have a single sentence, a single label, and usually you have a couple of categories, but it's not too big. So for somebody getting into NLP, whenever you're just starting, it's also conceptually easy to think about how to do this, as well as being easier to batch. Whenever you're doing training on these large models, it's important to be able to do it efficiently. So it's all kind of helpful in this way. So that's maybe one of the reasons that this is so pervasive. So today, what I really want to try to convince you is that sentence classification is maybe not always an ideal way to benchmark models. Now, this is not to say that all sentence classification is maybe incorrect, but that a lot of times we have a tendency to overuse sentence classification as a proxy for model performance. And there's a lot of caveats there. So I'll talk a little bit about some of the problems with sentence level classification. Starting off, I want to talk a little bit about the values that we have whenever we're talking about these things. So as a machine learning community, I take NLP inside of this. There are certain values that have a tendency to pop up more in papers than other ones. So Birhani et al., they looked at this paper called The Values Encoded in Machine Learning Research. They took 100 of the most cited machine learning papers in the last couple of years, and they annotated them for the kind of values that the papers were pushing forward in each part. And kind of unsurprisingly, you get this kind of a thing, right? Performance, generalization, efficiency, researcher understanding, novelty, and building on previous work. This notably leaves out things like robustness, robustness to bias, and several other things. And I guess what I really want to point out is that performance here is the main metric for what values we want to have, right? If you have a good model and it performs the best, then this model is likely to get accepted, or the paper is likely to get accepted into a high-level conference, and it's likely to be cited more often. But that has problems as well, right? I mean, when we're concentrating things on accuracy, F1 or BLEU score, it's helpful in a way because it allows us to kind of fairly compare models across a lot of tasks, and you don't have to think about too much. You just think about the performance, and you're fine with it, right? You don't have to think about, I don't know, all the possible variables between the data. We just think about the one metric, and it allows us to kind of focus on a single number and be happy when the number goes up. So it gives us a kind of objective criteria for whenever models are better. So a lot of times things happen like this, where we see these things where on many benchmarks we achieved superhuman performance. So we've gone past what humans can do. And the question is always whether that's true or not. And today I'll try to convince you that maybe that's not actually true. Right? So the case study that I'll be looking at is sentiment analysis. And here, what I've done is just given 5 of the most common sentence level classification data sets in sentiment analysis. So we have this movie reviews data set from Peng et al. 2002, a camera review data set, subjectivity data set, MPQA, and Stanford sentiment tree bank. And these are all kind of sentence level binary classification. So positive, negative, basically, except for the subjectivity one, which is subjective or objective. But these are a couple of examples, but there's actually quite a few more. I mean, there's tons of data sets that are out there at sentence level. This is only in English as well. So the current state of the art on several of these data sets is incredibly high, worryingly high, actually. The Stanford sentiment tree bank, for the binary one, like I said, the accuracy right now is at 97.5. For the movie reviews, 92.5, and for subjectivity, 95.5. So does that mean that these models are great, right? They should be incredibly good if they're able to do this. And we would expect them to be able to be relatively robust and things like this. I've had a lot of people actually tell me, seeing these numbers before, well, sentiment analysis is basically solved, right? Because I mean, if you're at 97.5, you're done. I mean, choose a different path, do something else, and move on. But having worked in this area for a while, I can relatively guarantee you that it's not actually as good as it looks. So yeah, not really. So me and some colleagues at the University of Oslo, we looked at, we had a paper called Sentiment Analysis is Not Solved, where we took a number of sentiment data sets, and we collected a subset of sentences that 4 models, so a bag of words, just as a kind of baseline, by AIST, Elmo, and BERT, which was state of the art at the time. And what we looked for was the errors that all of these made. So we took all of the data sets and collected a subset where all of the models failed. And then we went through and we annotated these for 18 possible categories. So it was things like, well, I'll talk about it in a second, but 18 linguistic and paralinguistic categories that could have led to the error. So we had some that were annotation related, things like incorrect labels. There were a lot of incorrect labels in these, which makes you think about if you're getting 97% on data with incorrect labels, what does that mean exactly? Right. A lot of things also that were data related. So things like non-standard spellings and emoji that the models had a lot of problems with, and set up things like negation, modality, amplifiers, etc. Right. There's a lot of kind of the interesting phenomena that seem to be located inside of these errors. So what I wanted to say with that is that the sentence level setup kind of hides the fact that models perform really poorly on certain subsets of the data, right? Things like negation, things like modality, and this kind of compositional knowledge. When you work at sentence level, you can kind of avoid that. You can work with heuristics to a large degree. And whenever you just take data off the internet that has been, I mean, you kind of filter for binary classification, filtering out all the middle, all the difficult parts, then it becomes quite easy to avoid that. Right? The other thing is that a lot of these data sets that I've just mentioned before are actually simplifications. So they're not the original data. This MPQA data set that I mentioned before is actually very, very complex, the annotation. So it's annotated for direct subjective expressions, indirect subjective, things like this, as well as targets and sources and all of their relationships. And we've actually, the one that most people use is just a sentence level reduction of this to binary sentiment. So we've removed all of the complexity and just kind of set to this easier sentence level data set. Same thing happens with the Stanford sentiment tree bank. This was a really interesting data set that's annotated for polarity at each node of a constituency tree. So each one was annotated separately. So what you get is this really rich, dense data set where you can look at things like compositionality. So for example, in this example we have here, the high level negation actually ends up negating all of the kind of positive polarity, right? And you see that very clearly here because it's been annotated. So you can train models on this. You can also test if your models are able to do this well, which is quite interesting. The problem is, again, the one people normally use is just the binary sentence level version. So people don't have a tendency to use this data because it's slightly more complex to work with. So yeah. And there's a lot of other sentiment data sets where this happens. Again, I mentioned sentiment because this is the area I know the best, but there's a lot of areas where this happens as well. So they've been converted to sentence classification and then further binarized. So you have to ask yourself whether that is actually something we want to keep on doing. And I guarantee these data sets are used very often when we're benchmarking models, at least in English. It's not something that happens only in sentiment analysis. Like I said, for things like language identification, a lot of times working at sentence level doesn't make much sense. So we have a tweet from a good friend of mine. And if you know the meme, you probably know this. Hello, lange in de bukser, my old friend. So hello, X, my old friend is a kind of meme that is constantly done through the internet, right? But here, if you're trying to predict the the language of this tweet, you're going to have a problem because there's not one language. It's a mix of English and Norwegian, right? And I'm sure this happens. I mean, this happens everywhere throughout the internet with all the languages. In the end, trying to do it at sentence level maybe is just not the right level to do this at. Right? So we have to ask ourselves if that's something we really want to keep on doing as well. To move on a little bit, another problem with the sentence level setup is that error analysis is quite difficult. Knowing whenever you have a sentence level prediction, what the change, what the part of the data was that led to that prediction is very complicated. There's been some work on that, so doing things like looking at saliency maps or attention maps of the predictions and trying to use some kind of adversarial maps to see if it's really that caused it. But there's been some back and forth, so I don't think it's entirely, I'm not entirely sure that this is a perfect way of looking at this. So there was these two opposing papers, attention is not explanation, and then attention is not explanation, which kind of go back and forth on whether it's a useful way of detecting, let's say, doing error analysis on a sentence level. And from my experience, I can also say that doing error analysis at that level, it makes it very hard. You're always making kind of subjective decisions about what could be the reason that the model made an error here. Finally, and this one I think is super important, sentence level prediction is not always particularly informative. Let's look at one example at least. Let's say if we have this model we were talking about earlier, it performs binary sentiment prediction, 97.5% accuracy. So it's superhuman level, it's incredible, right? What would it mean if that model predicts positive for the following sentence? James went to the store. What could it possibly mean, right? It's a model that's been trained on either positive or negative, so it can only output positive or negative. But it's ignored the fact that not everything in the world is positive or negative. Some things are just neutral, right? James went to the store. This doesn't have any sentiment. So we have to ask ourselves sometimes, when you have a model that does super, super good on a task, is that task actually interesting or not? And I would suggest that maybe in this case, if you're getting up to these levels, it's maybe not interesting anymore. Okay. So the elephant in the room, do these large language models reduce these problems, right? I mean, we've had this explosion recently in NLP of incredibly large language models that are able to do lots of things. I won't go into all of it. I'm not going to go into tons of detail about this, but what I want to do is just kind of point out some of the models that have come up. So we have things like, obviously BERT is the most well-known, but then you have GPT-2. In this case, it's just a little bit older, so GPT-3 doesn't exist yet. But we have things like GPT-3. I mean, if we go through model size, the BERT large had 345 million parameters, which at the time was incredibly large. It was a giant jump from all other model sizes. We go to the GPT-3 and we have 175 billion. And then I think just another one I've looked at recently is this Megatron from NVIDIA, Megatron Turing, which has over 500 billion parameters. So these things are getting very big. And at the same time, the performance, at least the numbers are going up. And they're going up very fast. So the gains in performance have becoming bigger and faster as it goes through. So this is a graph from the DynaBench paper from Kiel et al. 2020. And they plot here the saturation of benchmarks over time. These benchmarks include both vision and NLP, but I think we could kind of agree that the benchmark situation is basically the same these days in both of the fields. And as you see, as time goes by from 2000 up to 2020, benchmarks last less and less time before it gets up to human or superhuman performance. So this is something that we know that the numbers are going up. We just don't know maybe what's going on behind that, right? So another important point is that inside of these benchmarking data sets that we're using, so the things we're referring to here, sentence classification is very commonly used. And of the tasks used, a lot of times the largest gains are reported on these sentence classification tasks. So this is something that is also very important to take into account whenever we're thinking about this. So yeah, like I said, we get the better numbers. The gains on this Stanford sentiment tree bank have gone from Elmo being around 90, 91.8 to 94.9 with BERT, and then Electra Large was 97.1. And there's another one that I didn't mention, but I forgot to put here that is 97.5. So it's gone up quite a bit, very, very fast. And again, the question is always, the other thing about these large language models that's really interesting is that they're few-shot learners. So whenever the GPT-3 paper came out, this language models are few-shot learners. The interesting thing was that with very few, they don't have to actually fine-tune the whole model, actually give it just a couple of examples, and it would do almost as well as fine-tuning state-of-the-art models. So here's as an example from this on the superglue dataset. You can see that we have this kind of random guessing baseline, and then 0 shot, 1 shot, and few shot, the orange being the few shot with 32 examples. And giving it only 32 examples, it was able to get better than a BERT model that had been fine-tuned. So that was pretty amazing right there. And it turns out, obviously here it looks like the bigger the model, the better it is in this. But a couple years later, Schick and Schütze came out with a paper that showed that you don't need very large models to be able to do this either. You can do it with smaller models. So this was an example on superglue again with 32 training examples, but using Albert and their approach. And if you look at it gets as well or better than GPT-3, but using a model that's 3 orders of magnitude smaller. So it seems that they're really good at this few shot thing. And another example is from this Guo et al. Paper, making pre-trained language models better few shot learners. What they do is they show that there's a couple of tricks on using this prompting. Prompting is the idea that you can just give a couple of examples as input and then ask for the answer as output. And instead of having to train it, you just send it all in as input basically, and it learns from that. They showed that doing this a smart way, you can actually get really good benefits in hand. For example, with as few as 16 examples per category, you can have for example, on the Stanford sentiment tree bank, around 94–95% accuracy, which is quite impressive. The question is, do these actually lead to generalization? And unfortunately, there's a growing amount of evidence that they have serious limitations. I'm going to concentrate just on one of these limitations today, and we're going to look at negation as an example. I take negation as an example basically because negation is found in all languages in the world. It's a very pervasive thing, and it's something that humans can deal with very easily, right? If I tell you that a light is on and the light is not on, you can extrapolate to what that means. It turns out that language models cannot. So there was large language models seem to fail completely actually at handling most negation. That means, well, to give you a couple examples, there's a paper by Ettinger from 2020 in Tackle that's called What BERT Is Not. And they introduce a suite of psycholinguistic datasets, one of them being negation. And it seems that the models were completely unable to deal with negation. So if you ask BERT to kind of fill in a sentence, and you say, a robin is it gives you things like bird, right? A robin is a bird, a robin is a robin, a lot of these kind of things. If you say a robin is not it gives you things like bird, robin, etc. So it's not very good at figuring out what the difference is here. Kastner and Schütze do something very similar. They have some probes instead of the psycholinguistic tests, but they find the exact same thing for large language models. So this one, the original one was just on BERT, but then it's also been looked at in GPT-3, some other language models. So it seems like the bigger the model, it doesn't really help with this. So it's not a problem of training data necessarily or model size. Then we also have this one from Hossein et al., who do the exact same thing, but instead of just kind of a general one, they look at the task of natural language inference. and again, found the exact same thing, that on a negated, let's say if you take the benchmarks and look at the negated subset, the models perform quite poorly at these. And finally, we debated all this beyond accuracy, which it won a best paper award for ACL 2020. They found the exact same thing but also including, let's say, available sentiment classifiers that are in industry. So it's something that happens in academia, it's something that happens in industry. It seems to be quite pervasive right now. So that's kind of problematic. If these models that are getting this great percentage, they're getting great performance, but they can't deal with this simple, basic, universal concept of language, right? So another problem is that whenever people actually report this performance on these benchmarks, a lot of times, they don't actually provide any error analysis, right? So they give us the numbers and they say the numbers are this, and that's it. And the problem is later you don't really know. So a lot of these papers that I've shown have come out years after the original models were out. So we weren't aware of these problems that the models had until much later, despite the fact that they were probably there from the very beginning. Haven't changed much. So without doing these kind of error analysis, we can't really know where models fail. So it seems like it's not just a problem. The large language models don't really solve a lot of the problems that we have with this sentence level classification. So what can we do instead of sentence classification? Let's see, I'm gonna take a drink. First, I'll give a couple of options that I think would be maybe something interesting that we could do. The first one is a evaluation and maybe a reformulation of tasks. So if you have this kind of setup where it's one label per sentence, is there some other task that's more interesting that you could do that's maybe picking out several entities and the relations between them, something that's more structured prediction? And again, going back to my kind of running example, I'll go with sentiment analysis. So like Andre mentioned, we have been working on this task of structured sentiment recently. And just to give you an example of structured sentiment, this is given a sentence, you find all the opinion tuples, where a tuple is an opinion holder, an opinion target, an expression, and the polarity that kind of relates these. So that's basically saying, not just saying for a sentence, what is it, positive or negative, saying who thinks what is positive and why, right? So it's a lot harder to do. So to give you an example, we have this one, which is some others give the new UMUC 5 stars, don't believe them. Whereas some others is the first opinion holder. We have the new UMUC, which is the target, and then 5 stars, which is the expression. And then all of this is basically saying some others thinks that it's positive about the new UMC, and they say that it's positive because it's 5 stars. So it gives it a 5-star rating, basically. And we have the second sentence, which is don't believe them. So it has the don't believe, which is this negative expression, them as the target. And here the holder is implicit. So it's implicit, we understand it's the writer, but it's not actually there. So we have some flexibility here. We've been working on this for a while. So there's quite a few datasets available now in some of the languages. The largest ones are in Norwegian now and in English for this. So we have this Nurek Fine, which we recently released in Norwegian. It has 11,000 sentences, and it's quite well. I mean, it took a while to annotate. We took our time. And we're relatively proud of it. And the MPQA is the other large one in English, which has around 10,000 sentences. For other languages like Basque and Catalan, or let's say other Western European languages, Spanish, Italian, French, or Dutch, you have kind of medium-sized data sets available. So we have data for this, and like Andre said, we've actually started a SimEval shared task on this year. So this will be the first iteration. We're thinking about maybe doing further iterations in the future. So if you're interested in participating, feel free to. But going to the advantages, what are the advantages then of this setup versus this kind of sentence level setup? Quite a few. So the first one is it's a more realistic task, right? Again, looking at this kind of sentence level, like we saw before, John went to the store saying whether it's positive or negative doesn't make too much sense really. Whereas in this task, we could easily just have that as no prediction, and that would be a valid prediction here. Second one, it has more informative predictions. So if we actually get models that are able to do, let's say, this superhuman level of performance like we have on the binary one, the predictions actually be useful then, right? If you're able to tell who was thinking what about what, then it's a more interesting downstream task in that way. Secondly, it's also easy to perform an error analysis because you have all of the parts. So I've actually, for the shared task, I've actually set up some automatic error analysis scripts that will be running on all of the participants. So it's something that you can do a little bit easier than at, let's say, sentence level. And finally, it's also super hard to do well with simple heuristics. You can't get 50% with a simple baseline, right? You're going to get very poor coverage. You're going to get very poor things. So you have to actually be doing what you think you're doing to get good results for this task. It's not to say everything's advantages. It also has some disadvantages. The main ones being it's harder to annotate well. So this is not something you can do with crowdsourcers. We worked with trained annotators, and it took several iterations to be able to do it well. And even so, there's always some more difficult parts with that, right? So you have to look a little bit and decide how much is it worth it. And also, obviously, at the same time, because it's to do this, it's also more expensive. So you get less data for the same amount of money, basically. But I would argue that it's also more interesting data in the end. And also, I'll talk maybe a little bit about some ways to mitigate this problem at the very end. So option two, instead of, if we don't want to reformulate, we can also create some challenging data sets. So if you're going to do something at sentence level and you want to do it, make sure that it's at least a challenging, difficult problem. And there's a lot of ways that we can do this, luckily. So one thing is to use linguistics. So the paper we said earlier, this what BERT is not, took a lot of, a whole suite, a lot of tests that were available from linguistics, from linguistic annotated data, specifically psycholinguistics, and tried the models on these. So linguists, luckily, have been working for years on trying to figure out what parts of language should be easy and hard to do, and there's a lot of data out there that I think could probably be interesting to pull in here, and that would be great for NLP. So to give you one example, I think I already gave the example earlier, but this is an example from the paper, whereas we have a robin is a bird robin, and robin is not a robin bird. As you look for both of these, the predictions are basically the same. So that was the interesting thing from the negation one. But there's actually quite a few tests there, so it's not just negation. The other thing we can do is create challenging data sets using domain knowledge. So this paper I mentioned by Ribeiro et al., this Beyond Accuracy checklist, they introduce a suite basically that lets you program tests semi-automatically. So you can do things like do some sanity checks that your model is able to do well on some basic things. And you can also check that it's robust to certain kinds of noise. So the example they gave in the paper again was sentiment analysis, and we have this example of a template where it's I, negation, positive verb, the thing, right? So very short sentence, but the good thing is you can then have lists of negations, lists of positive verbs, and lists of things, and just double check automatically whether the model is able to do these things. Turns out, unfortunately, that the failure rate on these very simple things was 76%. So the models were failing on these very, very simple negations. At the same time, we also have this testing NER, so making sure that it's invariant to certain kinds of small changes. If you change, for example, a named entity in a tweet, like, thank you, we got on different flights to Chicago. If you change Chicago to Dallas, that shouldn't have a big effect on the output, but it turns out it does sometimes. So they introduced this software that basically makes it really easy to check this stuff really quickly, right? And it's not just for sentiment analysis, it's for lots of things, but it's a great idea to have something like this as well. Third, you can also use error analysis techniques to create challenging data sets. This is like the one that I mentioned before that I worked on with a sentiment analysis is not solved. So here, what you have is the idea that on your test set, actually, you have some kind of annotations that tell you what kind of phenomena are there. And then you can compare models across these different subsets of phenomena, right? So here you would have something like a reasonable model, it does okay at sarcasm the best, but better model does better on modals. And the even better model gets negation and then emoji and spelling the best, right? So you have a bit more of a behavioral explanation of what your model is doing, not just the primary number. And finally, you can also create challenging data sets using adversarial examples. So this DynaBench that I talked about earlier from Kiel et al., the idea is to have a model in the loop, so a strong model, and for humans to create examples that fool the model. So for here example, we have this, again with sentiment, but it's, you try to find examples that fool the model, and if it fools the model, then they automatically add it to the benchmark. If it doesn't fool the model, it gets filtered out basically. The hard part about this is doing it well to where you create a realistic kind of data set, because it's very easy to kind of fall into, let's say, simple ways of fooling models. But if you set it up well, it's a great way of creating benchmarks that concentrate on the difficult aspects of classification. And finally, the last option that I'll give you today is to change the annotation paradigm a little bit. So we've been talking about how these large language models are few-shot learners, and it seems like we're going to use these more often. And the great part about that is if they are learners, we can kind of change paradigms. So normally what we've done in the past is we've had a very large train set, right? Around 70, 80% of our data, small dev set and a small test set. What we can do now then is kind of flip that around a bit and have a small train set, a larger dev set, and a really large test set. And why is that interesting? Mainly because you could do two things. Before, the difficult phenomenon that we had in the data, we're normally concentrated a bit more in the train set just because of the size, right? But now if what we're doing is we don't have to worry about using as many examples, if we have models that can learn from fewer examples, then we can really concentrate on making larger test sets and make sure that the test set actually covers all the phenomenon, the difficult phenomenon that we want, right? And we can concentrate on that a lot more than making, let's say, incredibly large train sets. This also means that when we're making these decisions on annotation, we can actually prioritize test sets a little bit more, and with, let's say, less data, probably still have a really good, interesting benchmark for modern language models. Okay, so I'll conclude really quick. First, use sentence classification with caution, right? The performance really might not correlate well with downstream performance on other tasks. So be more than anything else. This is especially for people who are, I think people who are new to the NLP community, just come in, probably are not aware of these difficulties as well. Second, use the datasets as originally intended when possible. So try to avoid these simplifications that I mentioned before for the Stanford Sentiment Tree Bank or the MPQA. If possible, try to use the original data, because people put a lot of effort into that, but whenever you simplify it, people don't put as much effort, or they don't look through the data as well a second time. If you still really want to do sentence classification, I would suggest a couple of things. First, consider these additional kinds of valuation that I mentioned. So this checklist that I said earlier, DynaBench, or one of the many challenge data sets that have appeared recently for a lot of tasks. I would also say that for right now, a lot of these things are very much centered on English. So I think we need to start moving them quickly into other languages. As a community, we have moved into multilingualism relatively quickly, but it's something we still need to push really, really hard on. And also don't report just performance, right? With all of the available data that I've just mentioned, the software, an analysis of model performance and failure behavior is really a lot easier than it used to be. Okay. Second, if you're conducting an annotation project, like I said, I would consider annotating a more complex, realistic version of the task, if possible. Also try to include some other metadata that'll enable testing model behavior later. So if you have things like if you're able to search for things like negation, these kind of things, to know whether that's available in the test data, it'd be super helpful for looking at later. And it's whenever you're annotating is obviously the best time to do this. If you have to go back through later, it's a lot harder. So take the extra 5 minutes and add that in as metadata into the annotation. Next, concentrate a little bit on adversarial curation if possible. So trying to concentrate on these very difficult things that models aren't good at it. And also consider concentrating more on creating representative dev test sets than just really, really large training sets these days, maybe. So returning to the original question, is it time to move beyond sentence classification? As always, we're not going to give a simple answer. I would say it depends a lot on your task. But for things like sentiment analysis, emotion analysis, these kind of things, I would suggest that there we can move on, at least, minimally. Also, like I said, the data sets are often annotated for a different purpose. And we have models these days, models and data sets, to be able to do the full task now. So the baselines that we have for this structured sentiment data set, or the structured sentiment shared task, can run on your laptop, and they can be done in a couple of hours. So it's not something that you need necessarily tons of compute for to be able to get a baseline. Whereas before it was maybe a little bit more difficult. All right, so we can do it. Let's do it then. And that's all. Okay, thanks for your time.
All right, I guess we still have at least half an hour for questions. And I guess we'll do it this way. So you just raise your hand. I'm giving you the mic and turning the camera. Yeah, I will just turn the camera. I guess it will be easier. So that, yeah, here you are. Okay. Here you are.
I'll try not to spend the half an hour we have. Oh, thank you so much for your talk. Like I reciprocated all the points you've made, like completely, and like there are lots of things to talk about actually. Like together with my colleague Maria Tikhanova, we've spent like last year doing the aftermath of the glue methodology. There are a lot of problems with benchmarks, and some of them like they lead to the things like that. And I myself, like I was, I fell into this consideration that analysis is just basically solved until somewhere like in spring, I got this Hugging Face summary, and someone wrote like, why are state-of-the-art models so bad at sentiment analysis? And there were like basic examples that were absolutely obvious for people like to consider whether it's negative or positive, and like the state-of-the-art models from the superglue benchmark, they just completely messed it up. So the first question I'd like to discuss is like, in your paper that sentiment analysis is not solved, basically. Did you measure, the human benchmark on these complex tasks that are, difficult for the models themselves? So are these examples that you have filtered out, are they actually like difficult for humans too, or are they obvious?
Yep, thanks for your question. So we didn't actually do any inter-annotator agreement or something like this to check for it. But from my experience, I could tell you that most of them were relatively straightforward. There's some examples, there's some kinds of phenomena that are quite difficult. So things that require world knowledge to understand. A lot of times, for example, proximity to something that's nice could be a little bit more difficult for a model to see, or I don't know, star ratings, if they're different from one place to another, that could be a little bit complicated. Knowing whether, let's say, for a certain domain, if it goes to 5 stars, if it's a 5-star rating, it's good. But if it goes to 10 stars, that could be kind of bad, right? These kind of things, I think, are probably not easy for humans either. But at the same time, no, we didn't actually look into what the human baseline would be.
Thank you. So we've got like very similar results, but for the natural language inference task this year, actually. So, you know, in the GLUE benchmarks, there is the diagnostic data set, which is like the most rich annotated with linguistic features. And what we did actually, we have augmented this data set with the same format and have, you know, we had all the annotation from that format like preserved. And we have basically translated it into 5 European languages, experimented with the multilingual models. And what we got is like quite the same, like negation completely messes everything up. But other features like that are not expressed lexically in any way, some kind of complex syntactic features or semantic features, they also mess the models up. So they're also the problem while they are presented in the data. So they are not learned while fine-tuning procedure, you know. So like maybe we should, you know, reconsider our fine-tuning processes. And what actually was quite interesting, that adding more data to fine-tuning kind of helped. So some of the features that are at least expressed lexically, like some simple syntactic features, and some of negation processing was like better from epoch to epoch if we add more data. But if we don't have enough data, then we're doomed actually, and we cannot generalize over such data sets like diagnostics. Yeah. So how would you like put this into the context of other tasks? Have you maybe like, you know, dived into the results that the that are like given from the other tasks, not just sentiment analysis? Yeah.
Yeah, thanks. So other tasks, I mean, I haven't gone as far into for the sentence level kind of stuff, no. One thing I can say is for negation, this is something I've been working on for a while. So we have a couple of papers also on trying to get sentiment classifiers to do better with negation using multitask and transfer learning and things like this. And we get a little bit better, but honestly, right now, it doesn't seem like they want to learn negation. So I think there's a couple of things. One thing is when you're dealing with things at sentence level, to get a dense enough sample of the phenomena that you're looking at, and to make sure that that's the one thing in that example that changes the prediction, it's quite hard. So you really need tons and tons of data at sentence level to be able to pull this out. So I think that maybe if we kind of stop looking at things at sentence level exactly, we're looking at smaller sections, it might be a little bit easier to augment these things automatically, rather than trying to just kind of, you know, throw more and more data at the models and see if that's going to help. But at the same time, I'm not exactly sure about the best way of augmenting these things automatically. Like I said, I've tried with multitask learning and transfer learning, and had, let's say, so we had a couple of papers. What we try to do is we have some negation scope data sets available. And the idea was to either use that directly through transfer learning or multitask learning to, at the same time, have a single model that kind of learns from both things. So from the sentiment data set and also from the negation data set. And we had mixed results, let's say. So it seems like, I mean, we have one paper where it worked quite well, and then some follow-up papers where it has not worked. So I'm a bit skeptical about how good just doing that will be. Until we find a slightly smarter way of augmenting this.
That's the last one, I promised. Okay, yeah. I'm really happy that maybe this year we got like a few projects that address this problem. Like we have adversarial glue, by now we have robustness gym. Well, they basically do this thing. So they have the correlation analysis of what factors impact the model performance, like the length of examples, the other linguistic features, and so on. So basically, I had the kind of hypothesis. I don't stand by it lately, but maybe that's kind of interesting idea that while we have our models developing and the state-of-the-art numbers are increasing, then still we should just change the form of the task and it will still be complex and difficult enough for our models. For example, if we have a binary classification on sentences or text, that's like the simplest form, but then we can move on to, you know, sequence classification to show where are the features that are important. And maybe then after figuring out the features, we can move on to like sequence to sequence and implement the knowledge that we got. Maybe we should like move on to sequence with sentiment. I don't know.
Yeah, no, I agree completely. I think that's I think it's the kind of path that we should be taking now is pushing towards these slightly more complex tasks. We've gotten, like you said, on the basic tasks, we're doing good. We've gotten to that point that maybe it's not really interesting to keep on doing that. So yeah, I agree completely. Move on to sequence to sequence or sequence labeling, some kind of structured prediction in a way, right? Yeah. Thank you.
Any other questions? Yeah, I saw a hand there.
Actually, I have also two questions. The first one is don't simplify the task. Can you simplifying tasks? For example, have sentiment analysis. What do you mean?
So I'll go back to the slide that I had. Let's see, the first one here. Right here. So for example, the MPQA dataset is annotated something kind of like this, quite similar. What they did is just to create the binary one, you would just kind of go through and say, are there more positive than negative in this sentence? Then it's a positive sentence. Are there more negative than positive? Then it's negative. Is it exactly the same? We remove it. That's it.
Another thing that a little bit from another background, actually we do uncertainty estimation more of computer vision on everything, and I have the question about this because some of the example you show that, for example, an annotator can say that I don't have an idea how to correctly identify this and everything, but for model you're forced to say it's either this or that, and it's basically don't have this option. So how do you think how relevant is this addition for the model to like estimate that its own error or like on uncertainties for the NLP?
Yeah, great question, actually. So this has actually been a topic that's becoming more and more popular. There's a growing kind of workshop on this, and there's the idea is this kind of fuzzy representations rather than making a single argmax, right? So I think that on the one side it's a great idea. The problem is right now most of the data sets that we have haven't been annotated with enough annotators to know that. So to be able to kind of estimate the fuzziness of for training, you'd want to have at least for every data point several annotators probably to get this kind of, especially for subjective things like sentiment analysis where people don't always agree. It would be really nice to have that. The problem is that it makes annotation obviously that much more expensive. So you have to maybe triple, quadruple annotate everything you're doing in order to get a super interesting data set for that at least. And you have to think, one thing we haven't thought about very much, which I think it's starting now, is how to evaluate with that, right? Right now, whenever you're using F1 or accuracy, these are things that the community knows quite well, but once you get to start fuzzier kind of things, I think it's not something that NLP has worked with a lot in the recent years. But I think it's something that people are becoming more and more interested in. And I think that for things like sentiment analysis, it makes complete sense to start thinking about that. Having rather than a single prediction, having let's say a distribution over possible predictions, and then also using that to kind of estimate how likely it is that our model is correct or not. Right? But thanks for the good question.
Thank you for your great talk. I have several questions. I even wrote them down to not to forget, sorry. The first question is quite, just to clarify, you say that the models are few short learners, so we need to make train sets smaller and depth set and test set larger. So how do you think we should actually generate this train set, should we still be elaborate on what we are choosing to train, or we should do it randomly, like for example we do for the test set when we have large train, so just randomly split to train, dev, and test. But when we are few short learners, should we have less examples, but they still be versatile, so we should have a diversity, or it should be like generated like randomly as well, because it's more important to have a large test set. So what's your opinion on that? Thank you.
Okay, thanks, good question. So my feeling about that is basically that I don't think that I thought too much about how exactly to set up the train dev test split. I mean, I imagine you could do like we do these days, just kind of randomly, but just making sure again that in the test set, that's where you concentrate more effort, I guess. Whereas these days, I feel like a lot of times what people do is spend a lot of time annotating for the train, making sure that everything's nice there. And then on the test set, that's kind of where you go, okay, we have a little bit left over, and that's basically it. Whereas this would be kind of just changing the thought process, I think, is making sure that you have a really good test set. And then the dev and the train would be, let's say, not an afterthought, but at least would take second priority after making sure that the test set is really good.
Okay, thank you. And when I first saw the title of your work, I thought about, okay, we are going finally to speak about how to do, for example, sentiment classification, not for sentences, but for text. So my next question is, what do you think about text, and how should those texts actually be considered? Because, for example, when, I guess, everything that is expected from sentiment analysis, that when we read the text and we need to just to have like a score, okay, is it positive text, is it a negative review of something? So I guess, what do you think, how should the text be processed in terms of sentiment classification, for example? Thank you.
Okay, so I guess let me just make sure that I understand your question. Whenever what you're talking about is larger documents rather than just a sentence. Yeah, document level. This is, I mean, something that's been done quite a bit in sentiment analysis, at least, document level classification. And for me, it's still something that it seems a bit hard to put a finger on. So the data set we have in Norwegian, this Nurek data set, the original one is actually all document level. And there's some interesting things that happen at document level, especially whenever you have self-reported, let's say these were star reviews basically from 1 to 6. And you have interesting things that happen. So you have very positive reviews word-wise with very poor star reviews sometimes. So for me, at least, the concept of doing things at document level is a bit complicated. Reviews. Mainly because the star, well, let's say the final rating and the text a lot of times don't happen to coincide very well. So what I think might be more interesting is to kind of get this fine-grained version. And then after that, you can create a summary of that, which is quite interesting, to kind of create a summary of points that are positive and a summary of points that are negative, because that's in the end what people want more than, let's say, just a single number. You want to know, what are the, let's say if it's a review about a restaurant, you want to know what are the good things, what are the bad things, right? I think that would be quite interesting.
Yes, thank you. That was exactly what I was thinking about by asking this question. And the last thing that, yes, we're speaking about ranking, and how do you think about ranking? So is ranking, in your opinion, better than just binary classification, or still we shouldn't just stick to those numbers and do something to elaborate, to work more on something that is going inside? For example, some part of the sentence are positive, some parts of sentence are negative. So should we think about ranking rather than binary, or really go inside the sentence? Thank you.
Thanks. Yeah, it'll still lead to the same general problem when you have, for example, two sentences that are 97% accuracy.
Yeah, it's the most. Okay, can you hear us? Can you hear us?
Here.
It's turned on.
Okay, let's move on with the question.
Okay.
So where were we? Okay, any other questions from the audience? I actually have some questions, but I will gladly give room for someone else. No. Okay. Yeah, I can just probably stand nearby. So yeah, you mentioned adversarial curation, and that was when you were talking about the annotation process. So can you maybe elaborate more on that? Like, where do you see the place for this adversarial curation and how it should look like in your opinion, like on some practical example?
Yeah, I think for the one I was talking about was this dataset, which is done by Chris Potts and his group at Stanford. And their example at least was, I have it over here actually. Let me see if I can get to it. Nope, I got it. Nope. Further forward actually. Linguistics, and here we go. So here was one example that they have. So what they do is they have this model in the loop. In this case, I think they were using Roberta Large. And what they try to do is they give them a prompt. So in this case, it was this year's NACL was very different because of COVID. And the model predicts positive. And if you trick the model, then it's kind of adapted into the new part of the benchmark. So it's a kind of constantly evolving benchmark. So it has the advantage of that it's always difficult. It has the disadvantage that it's kind of hard to compare sometimes between versions, right? I think what you could easily do is just kind of set cutoffs, once every 4 years and do like a version control kind of thing, right? Exactly. And I think that's what they're planning on doing as well, something similar. This works really well whenever you have something that's easy for people to see, again, at a sentence level. I think for structured prediction problems, you have to think a little bit more about how to present this to people and smarter ways to do it. Right now, I don't have a very clear idea of how I would do this, for example, for our data. I could imagine, for example, giving them only certain parts that they could edit. If you gave them, for example, the first one that I had here, this example, you could give them, say, you can edit the expression. Please try to make the model fail just by editing expression, or edit the holder. And there you have a little bit more control over what people are editing. And you can make sure that it's not too far away, but if it still manages to fool the model, then that would be useful. But it's going to be, I think the hardest part with these kind of adversarial ones is getting interesting new phenomena in there, right? So it's hard to direct them towards, let's say, some of the phenomena that would be, that you know you want to look at.
Thanks. And then the next question or comment is more general and more provocative, maybe. So since you were talking about going beyond the sentence classification in this or that direction, either towards document level analysis or towards like more fine-grained analysis, isn't it the case that it would be great to simply just drop or discard the whole notion of sentence in natural language processing, since sentences actually do not exist, right? I mean, in real language, we don't have sentences. We don't talk in sentences. We don't even write in sentences. Well, we probably sometimes write in sentences, but written speech, yes, but written speech is, of course, sort of not the direct manifestation of language. So yeah, we talk in clauses, in utterances, but not in sentences. So maybe it was like a mistake from the very beginning to even start processing, analyzing, and evaluating NLP approaches in the sentence level. So is there any advantage in staying on the sentence level besides its simplicity? Sorry for being a bit wrong.
That's okay. No. So no. my inner linguist, at least, is telling me the exact same thing as you, which is sentences are made up. Most of the time in speech, we don't speak in complete sentences. We don't use these kind of things. It's a very different kind of situation, right? And since, at least for me, the feeling is that all of kind of speech processing, NLP, vision are coming closer and closer together regarding kind of methodologies. Eventually, we're going to get to a point where we're working directly with speech rather than this kind of text, which we're doing now, or some kind of processed version of speech, which is going to be more interesting anyways, right? So yeah, I would agree that at some point in time in the not so far future, it would be probably interesting to just move away from sentences in general.
Feel free to say something.
Yeah, when I first saw the title, we're talking about that level. Yeah, that's what I'm interested in. And your talk nails the summarizes the problems and the trends to solve them that exist in translation quality estimation, for example, very accurately, except where it doesn't go to the document level, because for a translation quality, document level is probably the more interesting level. So when you were talking about going away from sentences in translation studies, let's talk about segments, but there's a problem of how do you segment so if I can ask a question then, document level, how if you go away from sentiment generalize to other problems, what is the major problem with or processing?
So, I mean, for me, what I see as the main problem in lots of things is looking at what are the entities involved, what are their relationships, and what are the things that are going on, right? In the end, when we're thinking about, I don't know, the main difference between what we call sentences and what we're going to split it up into in a document is sentences normally have entities and they have a relatively simple relationship inside of that sentence. When you go to the document level, you have maybe lots of entities, you have lots of relationships between them. And right now, at least, we're not very good at dealing with all of these kind of relationships. You have things like, you know, co-reference resolution, bridging, all these kind of things that we avoid basically at sentence level. But it's going to be super important to get better at these kind of things. And also just kind of think, I mean, I'm not so good at, let's say, document level tasks. I haven't looked at too many of them. But I have the feeling that there's a lot of these kind of phenomenon that we're still not very good at, and we don't have a good representation for the document right now, right? It seems like for sentences, we have kind of smaller representation we kind of deal with, but when we get to this document level, we don't have a good way of keeping all that information in and their relations together regularly. I think that would be something that'll be at least useful and important to kind of work on in the future. Yeah.
Anything else? Other? No, I checked and there are no questions. Anyone else? Any other questions or comments or suggestions or anything? Nope. Okay. Anyone in the Zoom room? You can send your questions in the chat, or you can just unmute yourself and ask, just in case. And yeah, and if you are someone watching this talk on the YouTube live streaming, feel free to leave your questions as comments on our YouTube channel, and we will definitely yes, and we will definitely answer them later. And yeah, of course, follow our channel, put your likes, and subscribe. Feel free to follow us. But yeah, okay, so if you're absolutely sure that there are no questions, then you can still, of course, approach Jeremy. He's still with us today and tomorrow. So yeah, feel free to get in touch. And then I guess we can wrap up, and let's just thank Jeremy again. Yeah, and we now have time for lunch, and then we will meet again at 3, right? With the next session of NLP and something else in parallel. I'm sorry. SNA, yeah. Please check the schedule. Thanks a lot. Then we are wrapping up.